How you can use XRF for environmental compliance testing. When delving into the realm of chemical testing, one method that often comes up is X-ray fluorescence, XRF. XRF is an analytical technique that is popular in the electronics industry, especially for testing heavy metals like lead and mercury. How XRF works. XRF is famous for its non-destructive sample requirements. After being placed in the sample chamber, an X-ray beam hits the sample and induces fluorescence. What is fluorescence? Simply put, fluorescence is a process that occurs when an electron moves from a higher energy state to a lower energy state, represented by n equals 3 and n equals 2. This results in the electron losing energy, which is then released as a particle of light, also called a photon. The energy of the photon is equal to the energy gap between the two electron states. Since the amount of energy emitted is unique to each element, analyzing the photons will allow us to determine which elements are present in the sample. How fluorescence occurs in XRF. When the X-ray strikes an atom, it causes the atom to eject an electron from the lowest energy level, also called ionization. The instrument then directs the photons to a detector, which measures the energy of each photon and creates an energy spectrum. We can then analyze the spectrum to determine which elements are present. What can XRF detect? Unfortunately, XRF is limited in the compounds it can test for. It is only capable of detecting individual elements, such as lead, Pb, mercury, Hg, and nickel, Ni, rather than compounds that are made up of multiple elements, such as bisphenol A, BPA, or D, 2-ethylhexyl, phthalate, DEHP. XRF and environmental compliance. Since XRF excels with heavy elements, it's a great choice to analyze lead, Pb, mercury, Hg, and cadmium, Cd, restricted under RoHS. XRF cannot identify the remaining RoHS substances, PBB, PBDE, and the RoHS phthalate, since they are compounds. Gas chromatography mass spectrometry, GCMS, is a more suitable analysis method. Similarly, XRF would be helpful if you wanted to test for EU-REACH substances that contain heavy metals. Other applications for XRF. In addition to regulatory compliance, XRF is widely used in the electronics industry. One of the main ways is for quality control. Because of its non-destructive nature, quality assurance specialists often use XRF to verify the quality of finished products. For instance, you can employ XRF to validate the chemical composition of a steel alloy, ensuring its adherence to ASTM standards. You can also use the method for failure analysis since XRF can identify unexpected substances contributing to device malfunction. Sample preparation. It's worth noting that XRF is very popular in the electronics industry because, in most cases, it doesn't require the sample to be destroyed. If you have any questions about XRF, GCMS, or any other testing method, please contact EnviroPass for a free consultation.